Okay, for question 4, we're going to add one more variable, the forecasted weather. So we're going to go to jump, and we're going to say fit model this time, because fit model allows us to have more than one independent variable. So click on fit model. We're going to take our forecasted high temperature, that's one of the model effects. So model effects are a name that are given for the independent variables when you have more than one. We're going to take our total attendance, that's our dependent variable. And then we're going to take the forecasted weather, and this one is a categorical variable, and jump automatically constructs a continuous set of continuous variables that are called dummy variables that are used to fit this into a linear equation that is, as we've said, requires that you have two continuous variables. So that does all that for you behind the scenes. You don't have to worry about it. It understands that you want a standard least squares fitting of a straight line and the minimal report. If you look at the other two, these are interesting extra additional reports, but they might be a little confusing, so we haven't looked at them, so I suggest you stick with minimal report and click on run. And at this point it's showing you what the effects of the lines are. I think this is a little bit hard to interpret, so I'll skip that. It has the effect summary, so this has the effect here of showing you which variables have a p-value automatically already of less than 0.05. It actually shows you all of them. So we can see that both of these have a p-value of less than 0.05. And then when we go down to look at analysis of variance down here, we can see the overall model. So that's the first test that we want to do, looking at the F test. And we want to verify that, in fact, at least one of our coefficients, B1 and B2, are significant, statistically significant. So we already know that up here. Now this lack of fit is something I didn't talk about in class. It's the interpretation here is that this model needs more variables, but I'll close that out. And so let's see, I asked you to get the regression plot. That's the first thing that comes up. The effect summary, that's the next thing. Summary of fit, analysis of variance, parameter estimates, and effects tests. And so let's go back and look at jump here. And that's basically everything that we have here. And so let's get our magic cross, highlight everything, Control C. Go back here, say paste, paste special, bitmap, and there we go. So now we can do the same thing that we just did for single regression, and that is to say evaluate each of our tests. So our first test, summary of fit effect summary, the key statistics are looking at the F value here, as I said, and this is the P value then for F test and the P value for the whole model, so that's significant. Then looking at each of our overall effects, model effects. So this is looking at, in total, for high temperature and weather, both of these are statistically significant here. So we leave those in. When you see the parameter estimates, you're going to see p-values that are higher than 0.05 for certain values of the categorical variable here, such as cloudy and partly cloudy. All this is saying is that jump cannot distinguish between cloudy and partly cloudy, but as a whole, the forecasted weather variable is significant. So that's just like ANOVA when we did the Tukey test and we found that some variables could not be, or levels of a variable could not be distinguished, but overall there was a significant effect. So don't be thrown off by the fact that some of these p-values are not less than 0.05. And so that's, let's see, what else did I ask you for? So those were the statistical tests except for the residuals. So what do we have? We need to take a look at the residuals to see whether or not those actually got any better. So let's go back to jump, and for this we can say up here, go to the red triangle, and there are 4 different areas of reports that we can get. So the residuals are under factor profiling, under no effect screening, no under estimates. Let's see, row diagnostics, that's where they are. So you have to just kind of play around a little bit here to remember where everything is, because there's so much that you can get. So let's look at residual versus predicted, because that's what we got for single regression. And now does it look all that much better than what we had before? Notice that it does not give us a histogram because it can't do it when we have more than one independent variable going on here, but I will go ahead and grab that, and let's paste that in as well. I think I asked you to do it here. So paste special, bitmap. So are there large irregularities? Well, it looks like there are less irregularities than we had before. If we look at the first one up here, as here we had the irregularities seem to be spread out quite a bit more. But we still have those odd ones up here, so it still seems like there might be some other variable that we're missing at this point. But when we look at the business tests, we see the R-squared is up to 0.4. And this time, because it's multiple regression, we want to use the adjusted R-squared, because that takes into account that we have more than one variable. But it's very similar in this case, so 0.40. So before we explained 36, was it? 37% of the variation. Now we've explained 40%. So we really haven't done all that much better. Our root mean square error is still 736. What was it before? It was 752, so we got that down a little bit. So the overall evaluation here is to say we probably need more variables, passes tests, but business tests not really, because RMSE is still too high. So that's essentially what we've got here for this analysis question, and that's what I wanted you to do essentially for question 5.